translating a real problem into a mathematical framework is actually quite difficult. It's more of an art, actually, but it requires rigor and systematism. In this video, we will give a small introduction to this process using an illustration on a simple example. A mathematical model is a mathematical representation of a system or a phenomenon that we are interested in analyzing. And we do this in order to better study it. In the context of optimization, the derivation of a model is based on 3 steps. We need to identify first the decision variables. These are quantities that we can manipulate in the system that we are trying to optimize. We represent these decision variables by n quantities that are represented by real numbers. Then our system has an indicator that we would like to make as large or as small as possible. And the relationship between the decision variables and the value of this indicator is captured by a function called the objective function. So it's a function that takes the decision variables as argument and returns a real number, which is the indicator that we would like to make the biggest or the smallest possible. And finally, the third step consists in identifying the set of valid values for the decision variables. We denote this set by capital X, but we will see that most of the time we can characterize this set using equations and inequations. Let's take an example of a producer of wine, the Château Laupt-Himum, and the producer of wine would like to find the best production strategy for his wine. So the context of the problem is as follows. The chateau is producing both rosé and red wine using grapes that are bought from local producers. In the context of this area, they can buy maximum 1 ton of grape called Pinot at a price of 3 euros per kilo. From these grapes, they can make rosé wine, and it takes 1 kilo of grape to produce 1 liter of rosé at the cost of 2 euros per kilo. For the red wine, called Pinot Noir, it costs 3,50 euros to transform 1 kilo of grape into 1 liter of Pinot Noir. Once the wine is ready, they sell it. The rosé is sold at a price of 15 euros per liter, but for each 100 liters that is produced, there is a rebate of 2 euros on the unit price. For the red wine, which is sold at 23 euros per liter, there is a rebate of 1 euro for each 100 liters of red which is produced. So now the question is, how many liters of rosé and how many liters of red should be produced so that the profit that is generated by this production is maximized? So we proceed in 3 steps. The first step is the identification of the decision variables. We have 3 things to be decided in this context. The first is the number of liters of rosé that will be produced every year. We denote this by x1, which is a real number. Then we need to decide how many liters of red will be produced every year, and we denote it by x2, which is also a real number. Finally, we need to decide how many kilos of grapes we will buy from the local producers, and this will be denoted by x3, which is a real number. So it means that our vector x of decision variable belongs to R3. The second step in the specification of the mathematical model is the derivation of the objective function. In our case, we would like to maximize the profit. The profit is the revenues that is generated by selling the wine minus the cost to produce it. So let's start by calculating the revenue. For each liter of rosé, we make 15 euro per liter, which is the price that we sell it. But there is a rebate. The rebate is 2% for each liter that we produce. And we produce x1 liter of rosé. And it's a rebate. So the unit price or the unit revenue that we generate per liter of rosé is 15 minus the rebate, which is 2% of X1. Similarly, the red is sold at 23 euros, and here the rebate is 1% per number of liters of red which is produced. And it's a rebate, so we have minus here. So the total revenue is given by the unit revenue for the rosé times the quantity of rosé which is produced, plus the same for the red. So we have the unit revenue for the red, which is the revenue per liter, times the number of liters that is produced. So this is the total revenue. Now we need to calculate the cost. There are three parts of the cost. The cost of producing the rosé. So we have 2 euros per liter of rosé, which is X1. We have 3.5 euros to produce 1 liter of red, and we have X2 liters of red that is produced. And each kilo of grape is paid 3 euros, and we buy X3 kilos of grapes. So the total cost is 2x1 plus 3.5 x2 plus 3x3. It means that the total profit, the total benefits, is obtained by putting everything together. So we have the revenue from the rosé, the revenue from the red, minus the total cost that we have just calculated. And this is our objective function. So the last step in this process is the identification of the constraints. So first, we have a maximum quantity of grapes that we can buy. So X3 is the number of grapes that we buy, should not exceed 1 ton, which is 1,000 kilos. Then, as we discussed, 1 kilo of grapes produces 1 liter of wine. So the total quantity of wine that we can produce, X1 is the rosé, X2 is the red, cannot exceed the number of kilos of grapes that we have purchased. And finally, we need to impose non-negativity constraints. It means that we need to impose X1 to be greater or equal to 0, X2 to be greater or equal to 0, and X3 to be greater or equal to 0. Indeed, if we don't do that, it may happen that the solution provided by the algorithm will generate a negative number. And this negative number would be completely meaningless in our context. How do we interpret that we need to produce minus 10 liters of rosé? So these type of constraints are very important, although they are easy to forget because they are so intuitive in the context of the real problem that we don't think about making them explicit in the model. So when we put everything together, we obtain the mathematical model for the optimization problem. We want to maximize the function f of x, where x is the decision variables which belongs to R3. The objective function is defined as we have seen, which is the revenue minus the cost. And this is subject to the list of constraints that we have identified. The number of liters of wine cannot exceed the number of kilos of grapes. The number of kilos of grapes cannot exceed 1 ton. And each decision variable must be non-negative. The specification of a mathematical model is based on these 3 steps: identification of the decision variables, identification of the objective function, and identification of the constraints. The set of constraints is often characterized by a set of equations or inequations, but not always. And there are some constraints that are easy to forget, the non-negativity constraints. In many concrete contexts, the decision variables are meaningful only if they are non-negative. These type of constraints must be explicitly included in the mathematical model.